University of Washington's eScience Institute. As part of the University of Washington, we acknowledge the Coast Salish peoples of this land, the land which touches the shared waters of all tribes and bands within the Suquamish, Tulalip, and Muckleshoot nations. We are very pleased today to feature a talk by Yuan Hsiao, who is a doctoral candidate in sociology and a master's student in statistics at the University of Washington. He is also an incoming assistant professor in the Department of Communication here, also at the University of Washington. His major work explores the intersection of social media, social networks, and political behavior, and has been published in Political Communication, American Sociological Review, Social Forces, Social Networks, New Media and Society, Information Community and Society, among other outlets. His talk today is titled Evaluating the Mobilization Effect of Online Political Network Structures, a comparison between the Black Lives Matter network and ideal type network configurations. Just a note that we'll be using the Q&A feature of the webinar. So you can open the Q&A window with the button at the bottom of your Zoom window and type your questions there for the speaker to respond to. And you can do that at any time, and Yuan will answer those questions following his seminar. So thank you so much, Yuan, and welcome. Please take it away.
Thank you, Sarah, for the lovely introduction. And thank you for inviting me to present my work. I look forward to the Q&A and your opinions on all sorts of methods, finding questions, and future directions. So you notice the title is a little bit different from what was originally announced, but I thought this is a more compact version that captures the spirit of the talk. So it's called Mobilizing Through Online Political Networks, comparing hashtag BLM Sacramento and the network conditions of activism. Here's kind of the structure of how I envision this seminar to be. So I have a short self-introduction about myself, followed by the theoretical motivations of this talk. Then we're going to diverge into a little bit of what is agent-based modeling and how do we use it to combine digital data and to test social mechanisms. Followed by data methods and results, the implications. And finally, if we have time, I'll talk a little bit about my ongoing research projects that are related to the mission of the eScience Institute. So without further ado, as mentioned, I'm a PhD candidate in sociology and a master's student in statistics. And starting in fall, I'm also going to be an assistant professor in communication at UW. My main focus focuses on the fields of political communication and health communication. In terms of research areas, broadly it can be characterized as political behavior, social networks, and digital media. So I've done various works on all kinds, and here are a couple of examples of the type of work I do. For example, how social media shapes the emotions and feelings towards protest participation. Another line of research, for example, is how political opinion and political behavior are shaped by social groups and social networks, including how perceptions of protest violence differ by your political affiliation, or how the spread of radical religious ideologies depends on the social networks of the leaders. So kind of combining these three pillars of what I do, today's talk is going to be focused on the intersection of three broad areas. One is social networks, second is political communication behavior, and of course, digital media. To answer the question, so how does the structure of networks on social media relate to the participation in collective action, such as social movements, such as protests, or other large political movements? So I'm going to lay out the research questions. There's going to be a little bit of terminology over here, but don't worry, we'll get through this. So two research questions. First, what is the network configuration of digital networks, and how does it compare to stylized networks identified in the literature? So that's question one. The second question answers, is the network configuration of digital networks facilitative of collective action participation compared to stylized networks, and under what conditions? So by now, I think you might be wondering, Yuan, what do you mean by network configuration? And what do you mean by stylized networks? And what do you mean by conditions? Yes, there's a lot of terminology over here, but as we walk through this talk and I get into the codes and bits of it, these questions will be answered and hopefully we can reach a satisfactory answer. Okay, so broadly, the idea of this talk is motivated by large-scale protests such as Occupy Wall Street, such as the Arab Spring, such as Black Lives Matter. And the core idea is that a barrage of research have argued that in these protests, social media plays a critical role in the mobilization process. We can loosely call this broad, very large literature the connective action literature, as most refer to Bennett and Sedgwick's article on the logic of connective action. So we got books that talk about this, but we can use the last book that is on the screen, The Logic of Connective Action, to broadly characterize these vast literature. But how? How do we characterize it? The core idea is social media can do a lot of things according to these scholars. They can increase issue awareness, they can gather resources, they can influence mainstream media. But the central idea is, as Gabardo describes, no more concept has been used to explain the effects of social media than the concept of networks. So what exactly about networks? How do the connective action literature characterize networks? They describe digital networks as loose and spanning, with online users connected as different people use different terminology. Some call them the online crowd, some call them online spectators, some call this the logic of aggregation. But the core idea is that the networks is loose and spanning, reaches a lot of people, not tightly knitted. And then the second pillar of this theory is that social media networks act as a medium for other processes to transmit, such as the transmission of movement-related information, transmission of personalized frames, or it transmits emotions for collective identity. So in a very crude way, that's some of the argument. So we got on social media, we have these loose ties, have a broad reach, reaches a lot of people. Then we got this idea that networks act as a medium for information, personalized frames, and collective identity. So we combine 1 and 2, we got this proposition. The proposition of contact creates action, and broadening the reach broadens the mobilizing power, which aggregates this mobilizing power to large-scale collective action, like Occupy Wall Street or Black Lives Matter. So this idea that contact creates action and broadening the reach broadens the mobilizing power, it's very intuitive and it makes a lot of sense at first, but it actually depends on the conditions of diffusion. As Santola and Macy argue, when we look at the processes of network diffusion of social behavior, one can distinguish between simple contagion versus complex contagion. The critical idea in simple contagion is that the cost is very low and you just need one contact to activate diffusion, activate the adoption. Like, for example, liking something on Facebook. If somebody says, hey, Yuan, would you like this post regarding politics? I'm like, okay, sure, if it's not too outrageous, I'm just gonna like it. No problem, one person makes it all. But for other types of political behavior, such as attending a protest, when participation costs are high, one often needs multiple sources of contact to activate this type of adoption. So this is called the process of complex contagion. You need multiple sources. So if one person tells me, Yuan, can you come to the protest? I'm like, maybe. If a second person asks me, can you come? I'm like, probably. But when a third person, fourth person, fifth person starts to activate this idea of social reinforcement, that would really increase my motivation to participate in a protest. So how does this relate to the idea of networks? Loose networks benefit simple contagion processes, but often inhibit complex contagion. And the reason is quite simple. When the network is very loose and there's a lot of long ties, that implies that dense clusters or very close social groups are rare, and you don't have the multiple sources of contact to activate participation. So that leaves us with the puzzle in the connective action literature. If Santola and Macy are right, and if, according to the literature, social media networks are indeed loose with a lot of long-spanning ties, how can such a network configuration, facilitate high-cost collective action, such as the Egyptian revolution, which requires complex contagion processes. That's the puzzle. To solve the puzzle, I would argue that one would have to kind of take a step back and look at the different paradigms of how people look at the role of social networks in the diffusion of political behavior. For connective action scholars, the focus is on social networks as a medium to transmit culture, meaning, emotions, information, and other things. But for Santola and Macy, they look at it in a very different perspective. They look at it from the idea of networks as structure. They want to see what it looks like, the configuration, whether it has dense clusters, long ties, and other types of structural features of social networks. Because of this difference, they lead to very different conclusions. And the first talk is to bring a more structural perspective to the connective action literature. How can one understand the effect of network structures? There are many ways to do this, but one often used approach is the idea of agent-based modeling. The advantage of agent-based modeling is that it describes interdependent decision-making processes and how that relates to network structures. To get the idea of interdependence, so for example, whether I participate in a protest depends on what my friends do. Are they participating? And then what my friends do depends further on their friends. So you got this idea that whether I participate in something depends on my friends, and whether my friends participate depends on their friends, and what their friends do may depend on what I do. So there's all this interlocking decision-making processes that make things really complicated and very difficult to run a very conventional statistical analysis. And the advantage of agent-based modeling examines exactly this. It examines how complex macro outcomes arise from micro interactions through network relationships. So the advantage of agent-based modeling is that it can experiment with many theoretical scenarios. It can experiment under this network structure, this network configuration, what happens, and then examine a different one. For a network-based ABM, there are two components. One is the configuration of the network, and the second is the decision-making rule for the individual. So I know not everybody is very well-versed with agent-based modeling, and this might seem super complicated. So here's a toy example that shows what I mean. So let's say this is scenario one, and there are 4 people over here. So 2 on the left, not 2 on the left, 1 on the left, 1 on the right, 1 on the top, and 1 on the bottom. And you got some kind of behavior we want to spread. Let's just call it the red behavior. So I want to turn all people into red. So you also notice that there are 4 lines which indicate friendship relationships. So for example, these 2 people are friends. So that's kind of the setup. That's the network structure. 4 people, 4 ties, that's the network. And the decision rule is if one of my friends is red, I'm going to turn red. So this is iteration 1. And here's iteration 2. You can think of iteration as time. This is time 1. If one of my friends becomes red, I'm going to be red. So time 2, everybody becomes red because everybody has a red friend. So the proportion of red is 100%. Now let's switch a scenario and say, then the network is all the same, but the decision rule changes. If 2 of my friends are red, I will become red. Here's iteration 1. And this is iteration 2. The red proportion is still 100% because everybody has 2 red friends. So this person had 2 red friends. So this one and this one. So she becomes red. The right person also had 2 red friends, the top one and the bottom one, and he also becomes red. So everybody becomes red, and the red proportion is 100%. Okay, now erase all of that and look at now scenario 3. The decision rule is the same. If 2 of my friends are red, I will become red. But the network structure changes just a little bit. There was 1 tie over here that is rewired to here. So in other words, we still got 4 people, 4 lines, which indicates 4 relationships, but the network structure changes a bit. Now, what's going to happen in this scenario? Here's iteration 1, and in iteration 2, only the right person becomes red because only she has 2 red friends. The person on the left only has one red friend, so he stays yellow. And now the macro outcome, the red proportion has become 75% instead of 100%. So just by changing the network structure a little bit, it can change the outcome of diffusion dramatically. It changes by 25%. So that's kind of the advantage of agent-based modeling. It can allow us to examine very different network scenarios, and we can change the decision rules to examine what might happen in different diffusion settings. So for networks and agent-based modeling, two things matter. The decision rule matters, and the configuration of the network also matters, which leads us back to the question of connective action. I argued that the current limitations of current research is that not a lot of people formally investigate the configuration of digital networks in political behavior. And there are, to be honest, but then there's a little theorizing about how the configuration of digital networks relate to participation. And finally, there's very little attention paid to the effect of counterfactual networks in mobilization. So in my toy example, I presented three counterfactual networks, and examined the effect. So in other words, to make this simple, to understand the idea of counterfactual networks, let's say we collect data on some kind of political network on Twitter or some kind of social media. We examine what happens in our data set, but we don't know what happens if the network structure was rewired into a different structure. To really test whether the network structure of social media benefits participation, you have to have a control group, like an experiment. You have the treatment group, you have the control group. So when the treatment group is your social media network, what's the control group? You have to find a counterfactual network to make the comparison. So by now, you might ask, Yuan, this is very difficult. There are so many counterfactual networks one can imagine. You already showed me 3 examples, and you could have shown me more. So how can we determine which counterfactual networks to use? There's so many possibilities. Well, fortunately, that's not a problem for me, because political scientist David Siegel identifies these stylized network configurations. He can kind of think of them as archetype networks that are very commonly observed in real life settings. And I use these as the counterfactual networks. There are 3 kind of key abstractions: the village network, the opinion leader network, and the small world network. So the village network is a kind of network structure which, as the name suggests, composes of villages. So what exactly is a village? A village indicates that there are very dense clusters where people within the village connect to one another quite a bit, actually a lot. And there are only a few bridges or these long ties that reach other people. And consequently, it's very difficult to reach people from another village. So contrast that with the opinion leader network, when you have not villages, but a few core people with a lot of followers. And there's preferential attachment to create ties with those with more ties. In other words, you got a few leaders that have a lot of friends, but otherwise people are more or less scattered. So for example, in this little plot over here, you got one core member over here and one opinion leader over here. Finally, in the network literature, there's this idea of small world networks, colloquially called the 6 degrees of separation. The idea is you got moderately dense clusters, not like villages, moderately dense. You got a few long ties that span across clusters. And here's the critical part. It's easy to reach everyone in the network. So in other words, you can find anybody in the network within 6 degrees. So you might have heard that if you want to reach somebody in the world, you find a friend of 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 a friend, and then you can find it. So that's kind of the idea of a small world network. Okay, so I'm pretty sure that me and other people were like, what was the research question again? So let's come back and re-examine them. Research question 1, what is the network configuration of digital networks? How does it compare to stylized networks identified in the literature? So I explained what's a network configuration. It's the structure of the network, how people connect with one another. I examined stylized networks, opinion leader, small world, and village. Now let's jump to research question 2. Is the network configuration of digital networks facilitative of collective action participation compared to these stylized networks, and under what conditions? And when I say under what conditions, I mean under what kinds of decision rules, like in my toy example of agent-based modeling. So finally, let's get to the empirical data. The data in this case, it's not huge, but there's going to be a twist to it later on. The data is from the 1,215 followers of the Twitter account of Black Lives Matter Sacramento in 2017. I choose the Sacramento chapter for 2 reasons. First, it's empirically relevant for the Black Lives Matter movement because it uses Twitter heavily, so thus I choose Twitter. And then Twitter information regarding offline events is available for BRM Sacramento, but not other chapters. What I say by offline events is that a lot of movement accounts on Twitter, they have online activities that you can use hashtags and other things. But then in BRM Sacramento, to supplement these online activities, there are these offline events like community gatherings, like Black movie watching events, like protests, like rallies, demonstrations, and other political activities. And these information is available on Twitter. So before I jump to it, to my analyses, there's some analytical decisions on how to transform the data into something that's relevant. So I will remove isolates because they don't influence others and cannot be influenced. It's irrelevant for agent-based modeling. So an isolate means that the person has no ties to anybody else. So if the person has no ties, she cannot influence anybody and she cannot be influenced by anybody else. So kind of irrelevant for network diffusion. By the way, including isolates just kind of yields similar results. Then the question is, from Twitter data, how do I construct a network relationship? In this case, I construct a network tie if 2 users mutually follow one another. And here's the critical part. From the Black Lives Matter network, which I observe from Twitter data, I create stylized networks with similar density and size. In other words, I create the village opinion leader and small world network with similar density and size to the empirical Black Lives Matter network I observe on Twitter. So before I jump into my results, I want to talk about the trade-offs of Twitter data. So a lot of people use Twitter data, but is really Twitter data really great? There are some advantages and disadvantages. First of all, it often signifies less intimate relationships compared to other platforms like LinkedIn, or even Facebook. Well, that's the downside, but the upside is that there's more information on network relationships. We can track who follows whom easily on Twitter, but in Facebook and other medium, it's kind of harder to obtain public data on all of them. But more importantly, for this specific research case, it has contextual relevance. Black Lives Matter Sacramento used Twitter to mobilize its offline events and its online events. So it's empirically relevant. If I chose something like Instagram, that's kind of irrelevant in this case. But it also shows the importance when we want to understand political communication to use multiple research using different digital data, using Facebook data, YouTube data, or LHKG, which is a forum in Hong Kong. Because different cases have different contextual relevance regarding social media. And in some of my future research, I'll talk about a little bit of these kind of research topics relevant to different types of social media data. Okay, so to the results. Question 1, comparing the empirical network with the stylized network. I use summary statistics and I'll show the plot later. But to compare the 4 networks, you can see there are 4 columns: BLM, small world, village, and opinion leader. And you notice the number of nodes, number of ties, and the density are similar across the 4 networks. This is by design, because I observe my BLM network, but I want to know what happens if we had the same number of people, same number of friendship following relationships, but I organize the network structure into a small world or a village or opinion leader. So the number of nodes, number of ties, and density has to stay the same. Otherwise, it's comparing apples to oranges. So here's what differs. The transitivity of the Black Lives Matter network is kind of moderate, 0.2, similar to the small world network, smaller than village and larger than opinion leader. But when we look at the standard deviation in a degree, which indicates how many following relationships, how much variation in following relationships that each person has, is huge. It's kind of like the opinion leader and much larger than the small world network and the village network. Finally, I look at the diameter, which indicates what's the longest path to reach people furthest from the network. You can think of it as hard to reach nodes. It's also very large, similar to the village network and much larger than the other two stylized networks. So we got a network configuration with moderate degree of clustering, huge variation of number of ties per person, and many hard to reach nodes. Doesn't really fit any of the stylized networks at all. What does this strange configuration look like? I use a plot to look at it, to examine this. And here's what it looks like. Each circle is a person, each line is a network relationship. And first of all, you can notice this enormous, very dense cluster in the core, which explains the moderate degree of transitivity. But there are also many nodes in the periphery, explaining the diameter and large standard deviation in degree. And also, this is the critical part. You got these loose dyads, triads, and hard to reach nodes that are not observed in previous stylized networks. So it's kind of strange. And I call this unique network configuration with large dense cluster in the middle and many peripheral loose nodes. I term it the cluster connective network, which indicates that nodes within the cluster are closely connected, but nodes in the periphery have very few ties to others. So we got the network structure different from the stylized network, but how does that perform in hypothetical scenarios, that is in different decision rules compared to other configurations? So here's where I introduce my engine-based modeling decision rule. I use the network autocorrelation model, which is a common model for social influence. The idea is that the log of participation, so y equals 1 indicates participation, like turning red or some kind of adoption of social behavior. There's two parameters, alpha and rho wy. Alpha just indicates some baseline tendency to participate. Wy indicates how many friends are participating at the current moment. And rho indicates the influential power of friends. And I vary alpha and rho in the model. You understand what this means in a moment. So alpha indicates the internal motivation. For some types of political behavior, everybody wants to participate. And there are other types of political behavior, especially high cost participation, where the internal motivation is very low. So I have low probability, medium probability, and high probability, 3 scenarios of baseline participation probability. And then for rho, I have what indicates the degree of influence, which indicates how easily will I participate because of my friends. For example, again, I have low, medium, high influence. Low influence indicates that one participation friend indicates my participating odds by 20%. If it's medium, it indicates that if I have a participating friend, then it increases the odds of participation by 50%, and so on and so forth. In other words, I got 3 alpha possibilities and 3 rho possibilities with a total of 9 scenarios, ranging, for example, from low probability, high influence. Conceptually, this maps onto low cost activism and high cost activism when you alpha and rho. For example, if it's low alpha and low rho, it indicates the baseline participation probability is low, and it's very difficult to persuade others. And so here are the results. I've got 9 scenarios, 4 networks, and this is what it looks like. Now, this is very difficult to read, so let's zoom in a little bit. Here's one unfavorable scenario for participation, low baseline probability and medium influence. There are 4 lines, the BRM network, opinion leader, small world, and village network. X-axis indicates the iteration. You can think of it as the passing of time. And y-axis indicates the mean participation proportion. So kind of the red proportion in my toy example. It's pretty easy to find that the red line is higher than any other network. In other words, the BRM cluster connective network has a higher participation rate than other network configurations. But if we flip the script into a favorable scenario, that is high baseline probability and high influence, you notice that it's the complete opposite. All the other networks have higher participation rates, but the BLM cluster connective network has the lowest participation rate that lags behind. So in other words, we got a very strange scenario where depending on whether it's low cost or high cost participation, the BLM network can generate the highest mobilizing rate or the lowest. Now you might wonder, hey Yuan, these are hypothetical scenarios. How do they correspond to real scenarios, and how realistic are these parameters? As a kind of supplementary analysis, I estimate the statistical parameters for two types of participation. Online only activism is tweeting using the Black Lives Matter hashtag, and then tweeting about offline events in the Sacramento chapter. So in other words, I mentioned that there were these offline events like community gatherings, demonstrations, rallies, and other things. And if the person tweets about these offline events, I characterize it as tweeting about online mobilized offline activism. So I rerun my autocorrelation model, estimate the parameters, and rerun the agent-based modeling. I'm going to skip this. Rerun my agent-based models and show the results. So for the Black Lives Matter hashtag movement, I estimate that the alpha is 0.48 and the rho is 0.1, which indicates that alpha is an extremely common event, but the degree of influence is very low. Contrast that with online mobilized offline activism, where alpha is an extremely rare event and the degree of influence is medium to low. Note that these numbers should not be taken as the truth, but kind of give us a rough diagnosis of where these parameters lie. Is it more like online only activisms, or is it more like online mobilized offline activisms? I rerun my agent-based models and get a similar result. For the online hashtag movement with this very high baseline, the BLM network still underperforms, but these online mobilized offline events with the low baseline, the Black Lives Matter network outperforms. So here's the kind of takeaway of the results. It seems very paradoxical. How can a network configuration that was so effective for mobilization when conditions are unfavorable, that is in the low baseline, low influence scenarios, be relatively ineffective when conditions are favorable in high baseline, high influence scenarios? So it's in other words, this is very paradoxical. And I argue that the reason lies in the unique structure of the cluster connective configuration. When conditions are unfavorable, dense clusters are needed more than ever for complex contagions. So in other words, we got this large, dense cluster of the cluster connective network, which facilitates social support when conditions are unfavorable. But that's only one side of the cluster connective network. It also has lots of hard to reach nodes, which creates an upper ceiling effect on the upper limit of mobilization. These people only have one or two ties, and they're so far away from the cluster that it's very difficult to mobilize them. Therefore, you got this paradoxical result that even when conditions are favorable, these people just don't move. So what are the general implications for our study on social media and political processes? This study uses a structural network perspective to complement the networks as medium paradigm in the connective literature. The BLM Twitter network is not entirely loose, as scholars argue. It is loose in the periphery, but it's very dense in the core, the opposite of what people argue. And the study shows that these network configurations are important. The structure creates both facilitating and limiting effects. The dense core is significant because it creates the social support to weather adverse conditions. For example, in 2018, after the death of Stephen Clark in Sacramento, BLM Sacramento quickly mobilized a huge demonstration to block the Kings Arena of the National Basketball Association. So under difficult situations, mobilization on a certain degree is quick because of the dense core. But the loose periphery is also significant It shows that many mobilization efforts are within the dense core of the echo chambers. The loose periphery are left out of the network integration. And that creates the upper ceiling effect. So in general, the study moves from this question of whether digital networks facilitate participation. It's not a yes/no question, I argue. It's a question on the conditions which digital networks may or may not facilitate participation. It depends on the type of political diffusion we're talking about. So rather than fetishizing the all-present power of digital networks, the current study pinpoints the strengths and the limitations of network configuration. So that's kind of the general takeaway for the current study. I think I still got 3 minutes left. And I want to talk a little bit about ongoing research related to eScience. Previously in the talk, I talked about one needs to use many different types of social media data to understand the relationship between social media and mobilization. And that's kind of what I'm kind of doing right now. I'm using semantic network analysis to understand how frames, rhetoric, and how these media frames evolve and amplify on right-wing YouTube channels and on right-wing YouTube media like Fox News, One American Network, and other sources. So how these frames evolve and amplify. This uses YouTube data. In a separate project, I use LHHKG, which you can kind of think about as the Reddit in Hong Kong, to understand how online platforms generate these norms of unity to hold people together despite increased radicalization in the 2019 Hong Kong anti-extradition bill movement. In other words, here's the puzzle, one sentence puzzle of the movement. In the movement, people became increasingly violent on the streets, which often generates fractions or internal conflict. But how does social media hold people together despite these conflicts and differences in opinion about whether people should use violence in protests? Finally, I use agent-based modeling to understand how network mechanisms affect competitive diffusion. In other words, how network structures affect the diffusion of competing behavior. In the current study, I studied the diffusion often of one behavior, like a red behavior, it spreads. But in real life, scenarios are often competing diffusion. For example, Black Lives Matter trying to diffuse, but at the same time, Blue Lives Matter or All Lives Matter are trying to spread. In the arena of religious diffusion, different sects of religious organizations try to diffuse their religious ideology. So these kind of competitive diffusion processes are very common. And what I'm trying to do is to understand how network structures can help us understand the outcome of diffusion. Who has the most market share in the diffusion of these kind of competitive behaviors? With that, I think I'm out of time. So thank you for coming to the talk. I look forward to Q&A. Here's my contact. If you have questions, thoughts, just let me know.
Great. Thank you so much for the great talk. Please drop questions in the Q&A. And while we're waiting for questions to come in, Yuan, I wanted to ask you on the Twitter data that you showed for the BLM network, it looked, I know you talked about there being kind of one cluster, but it looked to me like there were two somewhat distinct, very dense clusters. I wonder if there's some meaning to that, or what you make of that, or if that's sort of just really seen as one bigger dense cluster, how you interpret that.
Yeah, so depending on the clustering algorithm, you can specify those as two clusters or one cluster. I tried to kind of model it, but it didn't really show us two clusters, but visually it does kind of show that there are kind of separate parts. But I kind of saw it as one dense cluster because there were so many overlapping ties between the kind of two blobs that I kind of characterized it as one. The critical part is that the diffusion of information when we study political communication, does it only touch one part of the network or the whole part? And in what I observed using the empirical data and using also my hypothetical scenarios, it seems to flow easily between the kind of, depending on what you think, the one cluster or two clusters. So in terms of theoretical implications, I think whether the specification of 1 or 2 has kind of similar outcomes.
Great.
Yeah.
Let's see. I was also wondering if there's, I don't know if you know, for these types of networks, if you've been able to do any comparisons with other BLM networks, and is there anything that we should be aware of that's sort of unique about the Sacramento network? I mean, I know you mentioned why you chose it, because you had this ability to assess both the activities that were going on and being shared via Twitter, and what was put up on the website. But I just was wondering, like, do you think that this is representative more broadly of BLM networks and maybe other types of networks in the space?
Yes, I think that's a great question. I indeed did collect supplementary data, which I didn't show in the slides, on 2 additional social media organizations. One is Black Lives Matter Philadelphia, and the other is Justice for Immigrants. I chose these 2 because, one, like you said, we want to be interested whether other BLM networks have similar configurations. And then I chose Justice for Immigrants because I wanted to understand political diffusion in other political movements than BLM. So what I found was that the configuration of those 2 networks were very similar to the Sacramento network. It's characterized by moderate transitivity, huge parameters and a lot of hard to reach nodes, and then a huge variation in terms of the number of nodes per person. So I would say it's pretty representative, at least in my 3 cases that I examined, that the cluster connective network is in fact. And I kind of think it's partially because of the algorithm of Twitter and other social media. It reinforces that you connect with people that you already connect with, and they're kind of reaching out recommendations. So it makes dense clusters very easily, but it also magnifies the difference, which indicates that if you're not in the social circle of the dense clusters, then you're easily left out. So that's why we have a dense cluster and a lot of surrounding nodes. And that's also why I think the online network structure is very different from offline network structures like the village, opinion leader, and the small world network, because the social media algorithms intensify the core. Whereas in a traditional opinion leader network, it's like opinion leader. Most people connect to opinion leader, but it doesn't really form that dense of a cluster. So that's kind of my take.
Great, thank you.
Yeah.
Nicoletta, did you have a question?
Yeah, so Yuan, that was a great talk. I want to say that I had a similar question. You talk about these clusters, the village-based opinion and small world. I was wondering if, like, across platforms, if they are similar or they differ as a function of platform.
That's an excellent question. What I did in this case is to examine a single social media and a single organization. But if we really think about networks, they are not constrained by organizations. You can see the Black Lives Matter Sacramento network as part of a kind of meta network of Black Lives Matter Philadelphia, Black Lives Matter New York, Austin, and other places. In other words, networks are embedded in networks. And in that case, although this is pure speculation for future research, I think in that case, it might look more like a village network, where you have a lot of connections within organizations. But then when you're looking at cross-organization networks, it might seem more like a village network. So in other words, how we conceptualize networks partially depends on the level we are kind of looking at. And thinking about cross-platform relationships, we might also see these kind of things. So not, for example, if we look at cross relationships between Twitter and Facebook, not everyone on Twitter is on Facebook and not everyone on Facebook is on Twitter, but there are some cross connections between them. So in my conceptualizations, you can see 2 dense clusters, which kind of seem like a village. But it's hard to officially state, but it will certainly look different than a cluster connected network, as in the case of a single platform, single organization network.
Thank you.
Yeah, thanks.
Thank you. We have a question. Oh, actually, Yuan, do you want to?
Yeah, I can see it
and see which one you'd like to select.
Yeah, so I see Carly's question. I was wondering if you could use a model to investigate political lean and change through networks instead of effectiveness of event participation. Yes, so this is where, so what I did is in the current study is to simply characterize whether people tweeted regarding an event. But it is possible to use text-based methods to characterize people's political affiliation, like whether the person is more Republican or whether the person is more Democratic. So that will give us a more richer understanding of not only political lean, but the types of political lean, which is what I'm kind of doing now on YouTube data. From YouTube data, you can extract the comments and then use something like LDA or some kind of topic modeling to understand how people talk about politics, and then combine that with network relationships. So great question. It's absolutely possible to do this, and I think that will enrich the analyses even more. Okay, so here's a question by Spencer. Here's the question. I wonder about other types of collective behavior among actors that cannot communicate over a long distance. Geese, for example, only communicate with other nearby geese. They don't use social media. How might this change the network structure? Yes, that's a great question. And that mimics the kind of more offline scenario. The advantage of social media is that it has a broader reach and it intensifies denseness. But what about other types of collective behavior where there are some constraints on degree, for example? I do think in those cases, it will form one of the three stylized networks, which is commonly observed in human behavior in offline settings. It will either be a village, it will be an opinion leader, or it will be some kind of small world network. So those are good characterizations of offline relationships. And you can think about why. For example, in the opinion leader network, it's a reflection of social hierarchy. For example, in chickens peck against one another to determine their social hierarchy. Or in the case of chimpanzees, there's often an alpha male, which everybody is connected to. In those cases, it's more like an opinion leader network. But there are other types of animal or human behavior where hierarchy is not so obvious, but then you have these dense relationships among communities, like in bees, or in more rural areas where there's not a lot of differentiation about social hierarchy. Then a village network will be a more accurate characterization. So in other words, the underlying social function, or in other words, the social roles of animals and humans will affect the type of network configuration. And that's where social media comes in. It changes, it's partially based on human nature, but the algorithmic changes the network configuration into something we haven't seen before, which I characterize as the cluster connected network. So I don't know if that's a good answer, but I do think there's some underlying micro mechanisms on social roles and social hierarchy that it would help us determine the type of network structure.
Great. Thank you very much for that answer. And you tied it into a lot of really nice examples from the broader world. Yeah, Spencer just also piped in the chat. Yeah, thanks for the answer and for the great talk. Yeah, so thank you again so much for the talk today and for getting us thinking about networks very broadly from humans out to geese and bees. And really look forward, we're delighted that you're continuing on at the University of Washington and looking forward to having chances to interact with you in the coming years. So congratulations on that appointment, and we'll look forward to hearing more.
Yeah, thank you for inviting me. Again, this was a great conversation. Thank you.
Yeah, you're welcome. Yeah, and we'll see you all next week. Sorry, yeah. Nicola, go ahead.
I just said thank you.
Great, thanks everybody.
Okay, yeah. Bye.
Yeah, take care.